Okay, I'm just going to walk through this one. I'm not going to write it all out. I want to use a linear approximation or linearization to find an approximate value for 62 degrees. Okay. First off, always remember, in this class, we always got to be in radians. Degrees are made up units. Degrees don't really exist. The universe knows nothing about degrees. We made them up. The universe thinks in radians. So at some point, I'm going to have to convert that guy to radians. Now, if I want to use linear approximation, I want some nearby angle, something close to 60 degrees that's a value I know, a sine value I know. So I'm going to write a little on here, but 62 degrees is near 60 degrees or pi over 3 radians. I know, because I know unit circle, that sine of pi over 3 is root 3 over 2. So anytime we're doing these linear approximations, we got to find some nearby x value whose function value we actually know. Otherwise, this wouldn't do me any good. Okay, then the linearization, the equation of the tangent line near pi over 3 is the original at pi over 3 plus the derivative at pi over 3 times x minus pi over 3. Remember, I'll write this again. L of x is always the original at the guy you're starting at, your starting point, plus the derivative at your starting point times your change in x. Okay, I'm going to need my original sine at pi over 3. We know that. That's a unit circle angle. And we're going to need his derivative. Derivative sine is cosine. Cosine of pi over 3 is a half. So now I'm just plugging in these two values here and here, and then my a value. This is the equation of the tangent line at 60 degrees at pi over 3 radians. So if we're thinking about the graph, 60 degrees is about here, pi over 3 radians. We're finding the equation of that tangent line right there. That right there is that line. Okay, now we got to convert 62 degrees into radians. So we just multiply by pi over 180. Now we're in radians. Then sine of 62 is approximately equal to, this is the actual function value. It's approximately equal to the y value on that tangent line. And you can see we've just plugged in, like you can check all the details here, and we get that value. So it's the same picture I just drew. So we're just a little bit above that point. You can't even see the space in between them. Now let's get our calculator out and see how good that approximation was. Okay, so I'll put my calculator in degree mode here, so we don't have to do the converting. Sine of 62 degrees. Our linear approximation said 0.883. Come on, to 3 decimal places, that's right. That's a good approximation. Okay, here, we'll do another one. I'll make one up. I'll do it on another video.